Hi, my name is Brian Shea. I'm a technical marketing manager for IoT at Arrow Electronics, and today I'm demonstrating a new product from Analog Devices. ADIS 1700X is a camera module with a CMOS imager from a company called Snap Technologies that Analog Devices acquired approximately this time last year. This particular CMOS imager is specialized for object detection and classification systems, and it has two specific features that are very unique for those systems. Number one, it has a very large pixel size to collect a great deal of light. It also features a logarithmic sampling, and those two features combined provide for a very wide dynamic range of up to 130 dBs. Why that's important is, imagine a surface parking lot application where I'm trying to monitor cars in a parking lot. That parking light might be very well lit in certain areas and shaded in other areas, and that illumination will change throughout the day. It's not acceptable in that application to see part of the parking lot part of the time. I need to see all of the parking lot all of the time. So one of the things that logarithmic sampling also provides me is, if you think about object detection and classification systems, they all rely on edge contrast data. Edge contrast data is the relationship of one pixel, the luminance of one pixel to another pixel. Luminance is simply the product of illumination and the reflection from the object. So what this logarithmic sampling does is, if I trying to get the contrast between two pixels, X and Y, if you do the math, the illumination term cancels. So now what I have is edge contrast data that is independent of illumination, and it is perfect for those types of systems or applications that have very variable lighting conditions. So if I go look at just the images coming off the camera itself, just the luminance data, it is a black and white imager. This is straight luminance data. But what is unique about this is that the imager itself actually outputs edge contrast data directly from the imager. So what I've done is I've reduced the amount of horsepower required by a host processor that is connected to the imager. So this is the basic operation that's required for these object detection and classification systems. So now I can start applying analytics to this application. So for example, motion is simply the relationship of one frame to another frame. So in this case, you can start seeing individuals walking because we're detecting the differences. I can put a hand there. If I stop completely, my hand should actually disappear, but that's kind of hard to do, but you get the idea. Other things done in object detection and classification system is blob analysis. So I can turn on blobs, and this is part of the analytics. So now I can start identifying people that are walking down the hallway here at the show. Or in this case, a parking application, individual cars sitting in a parking spot. So in this case, I've defined a region of interest with 5 spots, and all I really need to know is there a car in that spot or not. I don't need to send imaging data up to a cloud platform for an analysis. I'm putting the analytics at the edge of my system, right in the camera module itself. The camera module features a Blackfin BF707 400 megahertz processor, and that's enough to perform this edge analytics application. For more information, ADIS 1700X at analog.com.